Thank you, and welcome everybody to this project that we're working on. Quick thing I want to say is that this project is not just, this is not the end of it. It's a community project. So if somebody wants to contribute, we're going to keep working on this into the future. You're welcome to join. Really quick, I'll take it away with the problem and the opportunity here. So I have a deep background in teaching, both like high school students, but also undergrads at University of Florida. And I did find that a lot of students struggle with basic math concept. I mean, I'm not kidding when I say that. Like, I used to teach like junior and senior engineers, and some of them would struggle with like finding 50% of, let's say, 200 without a calculator. And it kind of goes to show that, math is this like beautiful subject, but it's taught sometimes in a way which is really mechanical and kind of takes the intuition out of it. I put up some data to kind of show that, like, especially after pandemic, the grade school performance in math is kind of going down. I personally know that trade professionals suffer with reasoning tasks in their certification exams. And while ChatGPT is great, I think that there's still plenty of like learning management systems and education apps that are still, they're using basically technology of the past year, and they still don't have any AI features. So the solution to that is essentially creating a ML model that can teach how to solve math problems, but not just that, but it could be tailored for like individual learning styles, because everybody learns things differently. One of our goals is also to be able to run it on consumer grade GPU. So you don't need like the infrastructure of, I don't know, $10,000, $20,000 machine to just run, how to solve grade school problems. And that would, with time, this can also like decrease the cost and latency that you might get from bigger systems. And this is something I'm actually doing is you can wrap up these services in an API and then offer it to existing products that don't have AI capabilities. And suddenly, once they integrate within their front end, now you have generative AI. So that presents a lot of market opportunity here. Let me move on to what we did and how we did it, and then we're going to show you a quick demo of where we got to. So for version 1, all we did is we took a pre-trained 7 billion Mistral 7B model, and we fine-tuned it using some techniques I'm going to go into. And then the demo is essentially asking it out of training that data set question, and then seeing the performance difference of a pre-trained model versus the fine-tuned model. To train it, we use the GSM 8K dataset, which is grade school math questions and answers. But we did something beyond just using the typical dataset, and we use techniques like that are, I think there's a paper called MetaMath, and what it does is that it'll take a question and it will essentially rephrase that question differently using like forward and backward reasoning, so that within the space of language, you can explore as many mathematical reasoning concepts as possible. Because at the end of the day, and this is a really important point, I don't think that the transformer architecture, the way it is implemented right now, the next token prediction, can really ever learn to like reason how humans do. It can produce reasonable outcomes. And so that's what we're after. We're trying to kind of bridge the gap between mathematical reasoning and how we can get there through language. And so essentially, we just take that thing, we use GPT 3.5 to bootstrap these different questions and augment the answers. We use zero-shot chain of thought reasoning. And, I think we fine-tune it. And I would let Mark take the stage and talk about what he did for fine-tuning as I change the slide. Mark, take it away.
Hello, everybody. So for the fine-tuning techniques, we used QLoRa, quantized LoRa, low-rank adaptation. And we use also 4-bit quantization method for the cost efficiency. And also at the left, you can see some kind of parameters for the epochs, batch size, and also learning rate. I also tried different kind of learning rates, smaller and bigger. And also at the right, you can see the instruction that we were given to evaluation function, and at the same time for the fine tuning formatting function. And we use this method for cost efficiency, and at the same time getting the best result from the using prompt engineering techniques. You can see from this prompt. And yeah, I think that's it. Back to the Sid.
Awesome. Thank you, Mert. Let's not waste more time and show you a quick demo. And let me just pause it before it goes away. And so this is built on Gradio, and essentially what we did is deployed it on like a Hugging Face inference endpoint, both the base and the fine-tune model. And here what I'm trying to do is essentially just take a question and then see how the base model versus the fine-tune model responds to it. So here's a quick video. It's less than 30 seconds. It goes by fast. Right. So the answer, by the way, here is 260. I think most of you can do the math in your head. Obviously, that's wrong. And then when I do the fine-tuning version of it, and this is all real-time inference, by the way, that's what you get. Right. And so kind of it goes step by step. It tells you, okay, Seattle has 20 sheep. Charleston has 4 times as many, so that's 80, and then it's 160, and when you add them all up, which is the right answer and also the right solution. Obviously, at this point, it's not really teaching anything. It is kind of thinking out loud in a way that makes sense, and sometimes that's sufficient. But what we're trying to do in the future really is tune it for teaching. And so kind of develop frameworks for how different students learn and how the model can respond in a way that would be conducive to their individual styles. And we also want to do like persona configuration. So maybe you have some UI, UX elements where people can be like, hey, I'm 16 or I'm 8 and I'll go to like 4th grade, or I'm like, 58 and I just started like, being a journeyman or whatever for electricians. And those are the different things that we're gonna work on, and there's lots of other ideas. But in terms of success criteria, I think obviously qualitatively, like if somebody comes and tells you like this is great, that's awesome. I had a student who was struggling with like quadratic equations last week, and she was just raving about this thing, which was awesome. And then quantitatively, obviously, we can kind of track usage and engagement and see how it correlates with like increased scores, if we can like have enough sample size of users who are using it to kind of, improve their learning. And that's really it. Questions?